Today is dividing exponents. Really only one property to give you, so I'll just give you the property. If I have a to the power of x divided by a to the power of y. Now remember, dividing is just another way to multiply. So here, the base is the same, and now I have my two exponents. What's going to happen here? This is going to be a to the x minus y. So when we're dividing, and the base is the same, we're going to subtract the two exponents. Here's the property. Let me give you an example. If I have 3 to the 5th divided by 3 squared, well, this would be 3 times 3 times 3 times 3 times 3. 3 multiplied to itself 5 times. Here is 3 times 3, 3 squared. Then we can cancel 3 over 3 being 1, 3 over 3 being 1. All we have left is 3 times 3 times 3, or 3 cubed, which would be the same as 3, 5 minus 2. Dividing says we can subtract them. This is 3 cubed, which of course, hopefully by now you're comfortable with, is 27. So pretty straightforward here, just one property to know. Let's jump right into some examples from worksheet 6.5. Let's look at 2e. So here we're starting to combine our properties. 45 m to the 7th n to the 4th divided by negative 9 m to the 4th n squared. So they were kind of nice to us in that it's all multiplication, division being a form of multiplication, and they've even put terms above other terms that are going to be easy for us to work with. Here, I'm just going to do some dividing right away. 45 divided by negative 9 is negative 5. Here, this is m 7th divided by m 4th. So this is going to be m to the 7 minus 4 is m cubed. Multiplied yet again here, because we're multiplying between each one of these. N 4th, n squared. Important that the base is the same, otherwise I couldn't use this property. This is n to the 4 minus 2 squared. Just like that. Let's look at h. 2h here. Negative 12 m to the 5th n to the 7th. Now these are all multiplied. When there's no symbol between, we understand it's multiplication. Negative 3 n to the m to the 4th n squared. Almost identical to this problem. I can group them in multiples like this. We're here to have 12 divided by a negative 3, negative is positive 4. Subtracting, because it's the same base of m, 5 take away 4 is to the 1st. Times, again, this is multiplication between each one of these. Same base of n, so I write n, 7 minus 2 to the 5th. Boom, just like that. Let's look at one that maybe is a little more complicated down at 4D. This whole group is being squared and then being multiplied to this whole group. Now, one way to do it is the old-fashioned way. You could say this is 3a squared times b, 3a squared times b, squaring it. Times, and then to cube it would be negative 2ab, negative 2ab, negative 2ab. So one way to do it is just to literally do exactly what it says, squaring this and then multiplying by that the cube. We could bring things together. But if you know your properties, it can be done easier. This squared can go to every term in the parentheses. So this is 3 squared, 3 times 3. A squared squared, a squared squared, a squared times a squared, b squared squared. Same with this cube can now happen to everything in this group. This is negative 2 cubed. Negative 2, negative 2, negative 2. A gets cubed. B gets cubed. Here we can do a little bit of cleanup. 3 squared is 9. A squared squared, we multiply a to the 4th. B squared, it's all being multiplied here, times negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8 here. I like to put it in parentheses so that I know the negative 8, it's not a minus 8, times a cubed times b cubed. So we can bring our like things together. 9 times negative 8 is negative 72. a to the fourth times a cubed. I'm going to add the exponents. So this is a to the seventh because I'm multiplying everything here. This is b to the first, if it's not written there. So b to the first times b cubed. I'm multiplying, so I'm going to add the exponents, b to the, to the fourth. 1 plus 3 being 4. Boom. Working it like that.